Hi everyone. So today we are looking at lesson 3.2, which is all about sampling, and we're going to look at good sampling and bad sampling. So just a quick reminder of our learning outcomes for this lesson. By the end of the lesson, you should be able to describe how convenience sampling can lead to bias, describe how voluntary response sampling can lead to bias, and explain how random sampling can help to avoid bias. So in your activity, I would like you to at least do numbers 1 and 2 of the activity, and then I give you the rest of the data. But I think it's important for you to experience how the data is collected. It's going to increase your understanding. So we're looking at the Gettysburg Address. We need to quickly choose a random sample of 5 words, write them in our notebook and or on a scratch paper, whatever, and look at how many letters are in each word, and then what is the average word length of your sample. So if you clicked on the Gettysburg Address, it comes up. And really, like, all you would need to do is just very quickly pick 5 words off of the page. And so then you would count how many letters are in each word. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, plus how many are 3, plus 1, 2, 3, 4, 5, 6, 7, 8, 9. And then portion has 1, 2, 3, 4, 5, 6, 7. And then cannot has 6. So we'd add those up, divide by 5 words to get our number that we are then going to put, or if we were in person, we would put on the class dot plot. So I went ahead and did some data for you. Okay. And so that number that we would have gotten back on the Gettysburg Address, we would have added to this data and then plotted it on our data plot. So part of what I want to talk about in this recap video is, what does each dot represent? So each dot represents the average word length of 5 words. Oops, got the R, words. Okay, so this is a representation of each sample. So each dot is a sample of 5 words. Okay, now I'm going to tell you that our true mean, if you took every word in the Gettysburg Address and counted the number of letters in each word and found the average, the true mean is 4.26. Okay, so when we look at our dot plot, okay, the true mean would fall somewhere right in here. Okay, so what do we notice about this? Well, the true mean is much lower than the mean that we got based on the convenience sample, okay? Or what we're going to call a convenience sample. This idea of just going in and picking 5 words will ultimately get you a higher number because our words are or our eyes are drawn to longer words. We tend to skip over shorter words quicker. Okay. We're more likely to quickly circle longer words. You noticed that I picked two out that were 9 and 7 and 6 letters long, and only one that was 3 letters long. But there's a lot of other words in the address, like a and the and can, that are really short that we didn't necessarily take account into when we personally picked our data. So, this method of just randomly choosing based on what we feel like doing is what's called a convenience sample. Okay, we just did what was convenient. It was easy to quickly pick our own um, data points rather than do it completely random. It may have felt random, but it's less random because our eyes are drawn more towards those longer words. So, what can we do about this? Okay, this isn't great data, right? If the true mean is 4.6, we definitely overestimated most of the time. So, convenient sampling tends to lead towards bias because it either overestimates or underestimates your data. So, what can we do about it? Well, there's good news. There's something called a simple random sample. Okay. And so rather than um, just picking a number out of our head or picking words off of a page, we can do it more systematically. So if you use a random number generator, and I mean there's a million of them out there now. Your graphing calculator has one. Your compute, like Google, will do it for you really quickly. You can ask your phone, like Siri or Alexa will do them. Random number generators are easy and convenient for us now. Okay, so using a random number generator, say our number generator gave us 5, 20, no, 5, 18, and 7 or whatever. So we would count to that word within the address and count the word length for that word. So if our first word or our first random number generator, oh my gosh, I'm having a hard time talking. If our first random number from the random number generator is 5, we would count to the fifth word, 1, 2, 3, 4, 5, and use that. Okay, and so in this word, we have 1, 2, 3, 4, 5 letters. Okay, doing that 5 more times. All right, you would end up, say, maybe the next word ended up being this one. All right, so whatever word number that is, that one has 4 letters. Okay. If it doesn't make sense to you how we're using the random number generator, send me a message because I would love to talk you through it a little bit more. I just don't want to spend more time on the video talking about it. So after we have used this random number generator system, I collected some more data and got us some new class data. So remember that the true mean of the Gettysburg Address is 4.26. So that falls like right here. Okay, so now what we can see is that using our method of a simple random sample, now we see that the mean for our data is much closer to the true mean of 4.26. Okay. And we can also notice the range of our data goes from 3.2 to 6.2 is smaller than the range of the data that we had before. We have less variability within our data. We have much more of our data points that repeat and are closer together. So let's answer this last question. Okay. So how is the dot plot from 4 different than the dot plot from 3? Okay, and the true mean for the average word length is 4.6. How does each dot plot compare to the mean? So I actually just explained it, so I'm not going to write it out. But if you need to rewind and watch it, you can. So I'll catch you back here in just a few minutes to talk about the notes and go over the rest of the learning objectives.